The automobile industry has been undergoing a major transformation over the past few decades, driven by the urgent need for cleaner, more sustainable transportation. Electric vehicles, EVs, have emerged as the frontrunner in this movement, with manufacturers like Tesla, Nissan, and General Motors leading the charge toward a future dominated by zero-emission vehicles. However, a new technology is poised to disrupt the electric vehicle industry and offer an alternative that could outpace the current wave of electric cars: the Toyota water engine. While the concept of a water-based engine might sound like science fiction, Toyota's innovations in hydrogen fuel cell technology combined with advancements in electrolysis, splitting water into hydrogen and oxygen, could bring forth a new era of vehicles powered by hydrogen extracted from water. This hydrogen can be used in fuel cells to generate electricity, which powers the car's motor. The promise of the Toyota water engine is simple yet transformative: clean energy production with a fast refueling time, longer range, and greater efficiency compared to the current generation of EVs. If successful, this technology could fundamentally alter the automotive landscape, potentially eclipsing EVs and reshaping the entire sustainable transportation market. Here's how the Toyota water engine could disrupt the EV industry. Number 1. Fast refueling versus long charging times. One of the most significant challenges with electric vehicles is the time it takes to recharge the battery. Even with the development of fast charging stations, EVs still require considerable time to charge, usually anywhere from 30 minutes to an hour to reach an 80% charge. While this is a dramatic improvement over earlier charging times, it remains a major pain point for EV owners, especially those who rely on their vehicles for long-distance travel. The Toyota water engine could offer a dramatic improvement in this area. Instead of relying on batteries, it uses hydrogen fuel cells, which can be refueled in under 5 minutes, virtually the same amount of time it takes to fill a conventional gasoline-powered vehicle. Hydrogen fuel stations, though still limited in number, are rapidly being built across the globe. If the infrastructure for hydrogen refueling were to expand at a similar pace to the growth of EV charging stations, the Toyota water engine would offer consumers a far more convenient solution for long-distance travel and quick refueling. By eliminating the lengthy charging times associated with electric vehicles, the Toyota water engine would make refueling as quick and easy as stopping at a gas station, which would significantly improve the convenience factor for consumers. This advantage could tilt the balance in favor of hydrogen-powered vehicles, especially for consumers who value convenience and speed. Number 2. Increased driving range without compromising weight. The range of electric vehicles has been steadily improving, but it is still a common concern for many potential EV buyers. The range of an EV is largely determined by the size of its battery pack, which in turn adds considerable weight to the vehicle. Even the most advanced EVs on the market today typically offer a range between 250 and 400 miles on a single charge, with larger models being at the higher end of that range. However, the larger the battery, the heavier the vehicle becomes, which in turn affects performance and energy efficiency. In contrast, the Toyota water engine could provide a significantly longer range without the need for an excessively large and heavy battery. Hydrogen fuel cells offer a higher energy density compared to batteries, meaning they can store more energy in a smaller, lighter package. Additionally, hydrogen itself is a highly efficient fuel, and a hydrogen-powered vehicle can travel significantly farther on the same volume of fuel when compared to an electric vehicle's battery charge. This advantage means that the Toyota water engine could offer superior driving range while maintaining a lighter vehicle. This could make the hydrogen-powered vehicle more appealing for consumers who are concerned about the range anxiety that continues to plague the EV industry. Toyota's emphasis on developing a lighter, more efficient system for storing hydrogen would help overcome one of the fundamental limitations of both gasoline-powered and electric vehicles: range and weight. Number 3. Hydrogen fuel cell efficiency over battery technology. While battery technology in electric vehicles has come a long way, there are still limitations that hydrogen fuel cells may be able to overcome. Battery electric vehicles, BEVs, rely on lithium-ion batteries, which are heavy, expensive, and require extensive mining for raw materials like lithium, cobalt, and nickel. The environmental impact of mining these materials, coupled with the energy-intensive process of battery production, raises concerns about the long-term sustainability of battery electric vehicles. In comparison, hydrogen fuel cells are relatively clean to produce and have a smaller environmental footprint when considering the full life cycle of the vehicle. Hydrogen can be produced using renewable energy sources like solar and wind, and the electrolysis process to extract hydrogen from water is significantly less damaging to the environment than the mining and production of battery materials. Additionally, fuel cell technology could potentially offer higher efficiency than the batteries used in EVs. The efficiency of hydrogen fuel cells is steadily improving, and the Toyota water engine could leverage this technology to provide more efficient energy conversion than is currently possible with batteries. In a fuel cell, hydrogen reacts with oxygen from the air to generate electricity, and the only byproduct of this process is water vapor, making it a cleaner, more sustainable alternative to current battery electric systems. Number 4. The challenge of EV infrastructure. One of the significant obstacles hindering the widespread adoption of electric vehicles is the lack of charging infrastructure. While the number of charging stations has increased dramatically, it is still far from sufficient to support the growing number of EVs on the road, especially in rural areas or regions with limited resources. For EVs to become truly mainstream, a robust and ubiquitous charging network is essential. Hydrogen-powered vehicles like the Toyota Water Engine could sidestep this issue by building upon an already existing infrastructure for hydrogen refueling stations. Although fewer in number than charging stations, hydrogen fueling stations have been expanding steadily in certain regions, especially in countries like Japan and parts of Europe. Hydrogen stations can be more easily integrated into existing gas stations or built as standalone refueling points, creating a more efficient fueling network for the future. If Toyota's water engine technology catches on, the company's expertise in developing hydrogen refueling networks could drive the rapid expansion of hydrogen stations across the globe. This would give hydrogen-powered vehicles a distinct advantage over EVs, especially in regions where charging infrastructure is still underdeveloped. Number 5. Reducing environmental impact beyond emissions. One of the primary reasons for the push toward electric vehicles is to reduce the environmental impact of internal combustion engine (ICE) vehicles. EVs are indeed zero emission at the tailpipe, but the carbon footprint of their production, especially the mining and processing of materials for batteries, remains a significant issue. In addition, electric grids in many parts of the world are still heavily reliant on fossil fuels, meaning that the overall environmental benefit of EVs is somewhat mitigated by the energy source used to charge them. The Toyota Water Engine, however, could offer an even cleaner alternative by using hydrogen produced from renewable energy sources. Since hydrogen can be produced using solar, wind, or hydropower, an entire system from fuel production to consumption could be powered by clean, sustainable sources, making hydrogen vehicles much more environmentally friendly over their entire life cycle. Furthermore, the simplicity of hydrogen fuel cells, which do not require the extensive mining and processing of rare minerals that are essential for battery production, would further reduce the overall ecological footprint of hydrogen-powered vehicles compared to battery electric vehicles. A new era in transportation. The Toyota Water Engine has the potential to revolutionize the automotive industry by offering an alternative to the current trajectory of battery electric vehicles. With fast refueling, longer range, greater efficiency, and sustainability, hydrogen-powered vehicles could become the preferred choice for a growing number of consumers. As Toyota continues to refine hydrogen fuel cell technology and develop the necessary infrastructure, the Toyota Water Engine could emerge as a serious competitor to EVs, altering the landscape of clean transportation for the better. The question then is not whether hydrogen will play a significant role in the future of mobility, but when it will surpass the dominance of electric vehicles.